Hello everyone, welcome to Astronautics for Exploit. In this video, I'm going over space colonies locations, planetary locations, natural satellite locations, space locations, Trans-Neptunian region, and beyond the solar system. Building colonies in space will require a combination of many factors, including access to space, food, construction materials, energy, transportation, communications, life support, simulated gravity using steady circular rotation, entertainment, and radiation protection. Several of these factors are discussed in this video. Space colonies are being proposed to be located in several areas and regions, such as planetary locations in the inner planets, such as Mercury, Venus, and Mars, outer planets, such as gas giants. Another area of location is the natural satellite, such as Earth's moon, Jupiter's moon, that is Europa, Callisto, and Ganymede, Mars moons, that is Phobos and Deimos, Saturn moon, Titan, and Enceladus. Space locations being proposed are space habitats, Earth orbit, Lagrange points, and the asteroids, while the Trans-Neptunian region, under proposition, contains Kuiper Belt and hot cloud, and beyond the solar system, involving intergalactic travel. Planetary locations. Inner planets Mercury. The potential benefits of having space colony in Mercury are as follows. Mercury is composed of 70% metals, whereas Earth's composition is 40% metal. Mercury's large core of iron and nickel accounts for 42% of its volume, while Earth's core accounts for 17% of its volume. Solar energy harvest. Mercury's proximity to the Sun will enable orbital solar arrays to gather tremendous amount of energy, which could be beamed to other planets in the solar system using a series of transfer stations positioned at Lagrange points. This picture shows Mercury as seen from the Messenger spacecraft. Extreme daytime temperatures. Mercury permanent colony is expected to be restricted to the polar regions due to the extreme daytime temperatures on the outer regions of the planet. The proposed colony, habitat sheltering. The proposed colony is for deep ground habitat so as to reduce effects of radiation, and also mobile habitats that constantly follow the terminator, which is the border between the day and night, referred to as twilight belt. Habitat velocities. Mercury has very long days and the planet is small, so the velocities of the habitats will be realistic. In these pictures, we have Mercury's northern polar region, provided by Messenger spacecraft, and Mercury colonization concept. Venus. The potential benefits of Venus colonization are as backup location for humanity. Venus is known as Earth's sister planet, and prospect of creating a backup location for humanity is one of the main reasons for colonizing and altering Venus climate for human settlement. Lower Earth risk. Humans living on Venus will be at lower risk of developing health problems associated with time spent in weightlessness and microgravity environments such as osteoporosis and muscle degeneration. Proximity to Earth. Venus' relative proximity to Earth will make transportation and communications easier than with most other locations in the solar system. In this picture, we have Venus as photographed by the Pioneer spacecraft in 1978. Potential benefits of Venus colonization. Launch windows. With current propulsion systems, launch windows to Venus occur every 584 days, compared to the 780 days for Mars. Shorter flight time. Flight time is also somewhat shorter since Venus is the closest planet to Earth. At its closest approach, it is 40 million kilometers distant in comparison to 55 million kilometers for Mars. Abundant natural resources. The fact that Venus is a terrestrial planet means that it has abundant natural resources which could be harvested, helping humanity to achieve a post-scarcity economy. In this picture, we have an artist's impression of a city that floats above Venus clouds. Venus size. Venus has roughly the same size as Earth, but just slightly smaller. Venus surface temperature. Venus surface is very hot and it has atmospheric pressure that is at least 90 times that at sea level on Earth. Its massive atmosphere offers a possible alternate location for colonization. The Venus dense clouds could be a possible source for the extraction of water. Venus gravity. The surface gravity on Venus is about 91% of the surface gravity on Earth. 100 pounds on Earth equals 91 pounds on Venus. Humans wouldn't suffer any of the side effects of microgravity. In this picture, we have artist's impression of Venus' thick atmosphere, complete with lightning strikes and sulfuric acid rains. Inner planet Venus. Venus Cloud City. Now, this is NASA's proposed high-altitude Venus operational concept plan. It is the concept of city floating on Venus. And in these pictures, we have artist's concept of a Venus Cloud City, which is part of NASA's AFOC plan. And the other picture shows AFOC mission approaching Venus planet. Terraforming of Venus. It is the hypothetical process of engineering the global environment of the planet Venus in such a way as to make it suitable for human habitation. In addition to creating a second home for humanity, terraforming Venus could also help to ensure that Earth remains a viable home for our species. The different terraforming steps are: reduce the carbon dioxide, recreate the oceans of Venus, and speed up rotation. In this picture, we have the artist's conception of a terraformed Venus, showing a surface largely covered in oceans. Mars. Reasons for colonizing Mars are curiosity, potential for humans to provide more in-depth observational research than unmanned rovers, economic interest in Mars resources, possibility that the settlement could decrease the likelihood of human extinction. Difficulties and access of colonizing Mars are radiation exposure during a trip to Mars and on its surface, toxic swell, low gravity, isolation that accompanies Mars distance from Earth, lack of water, and cold temperatures. This picture shows Mars. Similarities between Earth and Mars. The Martian day is very close in duration to Earth's day. Mars has a surface area that is 28.4% of Earth's, and Mars has an axial theta of 25.19 degrees, which is similar to Earth's 23.44 degrees. Differences between Earth and Mars. The surface gravity of Mars is just 38% that of Earth. Atmospheric pressure on Mars is far below the Armstrong limit, at which people can survive without pressure suits. Water on Mars is scarce, with rovers' spirit and opportunity finding less than there is in Earth's driest desert. This picture shows concept of a human Mars habitat. Mars terraforming. Hypothetical procedure transforming the planet from hostile to terrestrial life that can sustainably host humans and other life forms, free of protection or mediation, is referred to as Mars terraforming. The justification is that the presence of water and geological history that suggests it once harbored a dense atmosphere similar to Earth's. And this shows the concept of the process of terraforming Mars. Outer planets, gas giants, floating cities. The three farthest gas giants can be colonized using floating cities in their atmospheres. And the recommendation is to use hot, hydrogen-containing balloons to suspend large masses at roughly Earth gravity. Jupiter will be less suitable for habitation because of its high gravity, escape velocity, and radiation. This picture shows gas giants' planets. Natural satellite locations, Earth's moon. Benefits: proximity to Earth and lower escape velocity, allowing for easier exchange of goods and services. Drawback: low abundance of volatiles necessary for life, such as hydrogen, nitrogen, and carbon. Water ice deposits that exist in some polar craters could serve as a source for these elements. Alternative solution: to bring hydrogen from near-Earth asteroids and combine it with oxygen extracted from lunar rock. Surface gravity. The moon's low surface gravity is also a concern, as it is known whether 1/6 g is enough to maintain human health for long periods. The moon's lack of atmosphere provides no protection from space radiation or meteorites. The early moon colonies may shelter in ancient lunar lava tubes so as to gain protection. Day and night cycle. The 3-week day and night cycle makes use of solar power more difficult. This picture shows concept of a NASA lunar base. Jupiter's moons, that is natural satellite locations, the Europa, Callisto, and Ganymede. Volatiles. 3 of the Galilean moons, Europa, Ganymede, and Callisto, have an abundance of volatiles that may support colonization efforts. Artemis Project. The Artemis Project designed a plan to colonize Europa, one of Jupiter's moons. Scientists were to inhabit igloos and drill down into the European ice crust, exploring any subsurface ocean. This plan also discusses the possible use of air pockets for human habitation. Europa is considered one of the more habitable bodies in the solar system, and so merits investigation as a possible abode for life. This picture shows hypothetical ocean cradleboard in Europa. Mars moons, Phobos and Deimos. The moons of Mars have been proposed as targets for space colonization. Low delta V, change in velocity by the thrust of rocket engines, is needed to reach the Earth from Phobos and Deimos, allowing delivery of material to cislunar space, as well as transport around the Martian system. It has been proposed that the moons themselves may be inhabited with methods similar to those for asteroids. A space elevator on Phobos, a marine moon, has also been proposed. This picture shows Phobos. Phobos Supertete is a proposed space elevator on Phobos, a Martian moon. Due to its anchor being one of Mars' moons, it shares its orbital period, making a full trip across Mars' equator once every 11.1 hours at a speed of over 1900 kilometers per hour. The counterweight and base station at the far end are for launching vessels and cargo throughout the solar system without the use of expensive warp fuels. This picture shows Phobos Super Tete, Saturn moon, Titan and Enceladus. Titan is a target for colonization. Titan is a suggested target for colonization, and this is because it is the only moon in the solar system to have a dense atmosphere and is rich in carbon-bearing compounds. Life support. Titan is identified as possessing an abundance of all the elements necessary to support life, making Titan perhaps the most advantageous locale in the outer solar system for colonization. Human colonization. It was stated that Titan is the most hospitable extraterrestrial world within our solar system for human colonization. This picture shows Saturn's moon Titan. Enceladus is a small icy moon orbiting close to Saturn, notable for its extremely bright surface and the geyser-like plumes of ice and water vapor that erupt from its southern polar region. There is an ongoing research to determine if Enceladus has liquid water. If liquid water is found, then Enceladus will join Mars and Jupiter's moon Europa as one of the prime places in the solar system to look for extraterrestrial life and possible future settlements. Other large satellites, Rhea, Iapetus, Dione, Tethys, and Mimas, all have large quantities of fluorides, which can be used to support settlements. This picture shows Enceladus, possibility of fresh ice detected. Space locations. Space habitats. A space habitat, also called a space colony, space settlement, habitat, orbital settlement, or orbital colony, is a more advanced form of living quarters than a space station or habitation model, in that it is intended as a permanent settlement or green habitat rather than as a simple way station or other specialized facility. No space habitat has been constructed yet, but many design concepts with varying degrees of realism have come both from engineers and from science fiction authors. And this picture shows space habitat concept. Motivation of space habitat. Some of the motivations for space habitats are survival of human civilization and the biosphere in case of a disaster on the Earth, natural or man-made. Huge resources in space for expansion of human society. Expansion without any ecosystems to destroy or indigenous peoples to displace. It could help the Earth by relieving population pressure and making industry of Earth. This picture shows Blue Origin space habitat concept. Advantages of space habitat are access to solar energy, outside gravity well, in situ resource utilization, asteroids and other small bodies, population, zero-G recreation, and passenger compartment. This picture shows a rendering of a toroidal, donut-shaped space colony. Earth orbit. Advantages of orbital colonies are orbits close to Earth can be reached in hours, whereas the moon is days away and trips to Mars take months. There is ample continuous solar power in high Earth orbits, whereas all planets lose sunlight at least half the time. Weightlessness. Weightlessness makes construction of large colonies considerably easier than in a gravitated environment. Astronauts have demonstrated moving multi-ton satellites by hand. This picture shows orbital space colony. Zero-G recreation is available on orbital colonies but not on the Moon or Mars. The level of pseudogravity is controlled at any desired level by rotating an orbital colony. The main living areas can be kept at 1G, whereas the Moon has 1/6G and Mars 1/3 G. 1G is known to ensure that children grow up with strong bones and muscles. Disadvantages of orbital colonies are lack of materials. This may be expensively imported from the Earth or more cheaply from extraterrestrial sources. The Moon, which has ample metals, silicon and oxygen. Near-Earth asteroids, which have all the materials needed with the possible exception of nitrogen, comets or elsewhere. This picture shows space settlements. Lagrange points. The 5 Earth-Moon Lagrange points are near-Earth possibility. Many of the Lagrange points will have near continuous solar power capability, since their distance from Earth will result in only brief and infrequent eclipses of light from the Sun. The 5 Earth-Sun Lagrange points will totally eliminate eclipses. Only L1 and L2 will be reachable in a few days' time. The other 3 Earth-Sun points will require months to reach. The Lagrange points of L4 and L5 tend to collect dust and debris, while L1 to L3 require active station keeping measures in order to maintain a stable position. This makes them less suitable places for habitation. This picture shows 5 Earth-Sun Lagrange points. Space locations, the asteroids. Colonization of asteroids will require space habitats. The asteroid belt has significant raw material availability. The largest object being Ceres, and it is thinly distributed as it covers a vast region of space. Uncrewed supply spacecraft should be practical with little technological advance, even crossing 500 million kilometers of space. The orbits of the Earth and most asteroids are very distant from each other in terms of delta V, and the asteroidal bodies have enormous momentum. Rockets or Mars drivers can perhaps be installed on asteroids so as to direct their path into a safe course. This picture shows main asteroid belt. Trans-Neptunian region, Kuiper belt. The Kuiper belt is a circumstellar disk in the outer solar system, extending from the orbit of Neptune at 30 astronomical units to approximately 50 astronomical units from the Sun. Like the asteroid belt, it consists mainly of small bodies or remnants from when the solar system formed. Kuiper belt helps with terraforming Mars. These pictures show Kuiper belt. The Oort cloud. Oort cloud is a theoretical concept of a cloud of predominantly icy planetesimals proposed to surround the Sun at distances ranging from 2,000 to 200,000 astronomical units. It is divided into 2 regions, a disk-shaped inner Oort cloud or east cloud and a spherical outer Oort cloud. Both regions lie beyond the heliosphere and the interstellar space. This picture shows an artist's impression of the Oort cloud and the Kuiper belt. Beyond the solar system, the colonization targets. Beyond the solar system, there are up to several hundred billion potential stars with possible colonization targets. The difficulty. The main difficulty is the vast distances to other stars, roughly 100,000 times farther away than the planets in the solar system. Space colonization technology could in principle allow human expansion. This picture shows Taurus-based generation ship. Hypothetical starship concepts proposed both by scientists and in hard science fiction include a generation ship, a sleeper ship, an embryo carrying interstellar starship, a nuclear fusion of fission-powered ship, e.g. ion drive, a Project Orion ship, a nuclear-powered concept proposed by Freeman Dyson, laser propulsion concepts, uploaded human minds or artificial intelligence. This picture shows artist's conception of the national reference design for the Project Orion starship powered by nuclear propulsion. For more information, contact Astronautics for Exploit. Thank you.